Today, we are going to be talking about genetic mapping and linkage on chromosomes. Specifically, we will discuss three linked traits in cats: the cat's coat, pattern versus solid, tail length, short versus long, and eye type, normal versus cross eyed. In this experiment, we made a pure breeding, cross eyed, patterned, long tailed cat to a normal eyed, solid, short tailed cat. Below are the chromosomes of the two parents with their specific alleles marked on each loci. The resulting F1 offspring is a trihybrid heterozygous cat that we will test cross, and here's its chromosomes and marked loci. Using reverse mapping, we can look at the genetic map seen below and predict the probabilities of each crossover event happening, as well as the probability of getting a specific gamete from the F1 trihybrid. As you can see, one chromosome inherited from the father is on one side of the map, and the chromosome inherited from the mother is on the other side of the map. From here, we will make predictions of each crossover event happening, starting with a double crossover event. To determine this, we multiply R1 by R2 by the coefficient of coincidence. We can continue following the formulas in the table below to determine the probabilities of each of these events occurring. Now that we know the probability of each event occurring, we can put a face to the numbers we have calculated below. Here are the 8 gametes that can be produced from the F1 trihybrid and what event must take place for them to come about. Now that we know the 8 possible gametes as well as the probability of each event happening, we can now calculate the probability of getting a specific gamete from one of these events. For example, what is the probability of getting a cross-eyed, solid coat, short-tailed cat? First, we must identify what event this is. As we can see, this is a single crossover position 1 event, which we know has an 18.23% chance of happening. When we have single crossover at position 1, we get cross-eyed, solid, short, but we also make normal-eyed, pattern, long gametes. And as we specifically only want the first gamete, we will multiply our single crossover 1 probability by 0.5 to calculate the chance of getting this specific gamete, which is 0.0912. Let's look at another example. Let's say we want to predict the probability of getting the big E, little a, little t gamete. First, we need to identify which event this is, and as we can tell, this is a double crossover event. Like before, in the single crossover event, a double crossover produces 2 gametes, but we are only interested in one, the normal-eyed, patterned, short-tailed gamete. So we will multiply the probability of double crossover by 0.5, which results in a 1.28% chance of getting this gamete.